Hello, welcome back. Today, let's try to solve another Leetcode problem. 2817, minimum absolute difference between elements with constraints. So for this problem, basically we are giving an array nums, and we are also giving a value x. So this x means the distance between two numbers. Yeah, the distance means the index distance. Yeah. So for example, for the distance so for the first index number 4, so with a distance of number 2, it means more than or equal to 2. Yeah, so it should be 2. Yeah, and 4. So what is the minimum? So the minimum should be 0 because 4 and 4 is the same number. Yeah, so the final return should be absolute of the nums I minus nums j. Yeah, so this means the final return should be two numbers which the distance is more than and equal to this x. So the x is 2. Yeah, so we can find some pairs like this 4 and this 4, so the result is 0, and this 4 and this 2, so the result is 2, and this 3 and this 4. Yeah, so the distance is the final return is 1. But we need to return the minimum, so the minimum is 0. So how to solve the problem? Let's check the length of the nums. It is 10 to the power of 5. Yeah, and the nums I 10 to the power of 9. So for the x, it is in the range between 0 to nums.less. So this means we cannot solve the problem use n square. Yeah, for example, if we use n square like this, so x equals to 2, this means we're gonna first enumerate the index from the x, so it is this number 2. So we're gonna compare with this number 4 because the distance is more than or equal to, the distance is 2. So here we got a value, it is 2. Now we shift to the next number, it is 4. But for us, we need to compare with this 3 and 4 because this 4 and 3 to this number 4, the distance is always more than and equal to 2. So the result would be 0 because 4 minus 4 is 0, 4 minus 3 is 1, but we need to return the minimum, so this is 0. Yeah, if we look like this, first 2 with 4, the second 4 with 3 and 4, this is like a sliding window, the distance is more than or equal to 2, and the time complexity is O(n) square. But we need to use like something like O(n) or O(n) log n to solve the problem. Yeah, for O(n), it's impossible. Maybe we can use n log n. So how should we use n log n to solve the problem? If we can search the numbers, for example, this is a number 4. Inside is 3 and 4. If this 3 and 4 is sorted in sorted order, if we can use binary search to sort it, yeah, this means we can find the number closest to this number 4. Because in binary search there is also bisect left. So for the bisect left, it means we're gonna insert a number into this sorted array for 3 and 4. We can insert it and find the closest position. But for us, we're gonna use the sorted list. So for sorted list, it is a Python library. It is designed in 2016 and it's really famous. Let me go to the sorted list. So for the sorted API, as we can see it, so the GitHub star that is more than 3,000, and we have basically sorted list, sorted key list. But for our problem, we just needed to use the sorted list, and a lot of operations. But most of the operations, you can see that it is just log n time. So this is why we can use the sorted list to solve our problem. Yeah, but for sorted array, basically you need to insert the numbers inside. It's not possible. If it is an array, for each time you have to sort the array. But for sorted list, you don't need to do anything. If you insert a number inside your sorted list, it is only log n time. So this is why for sorted list we can use the n log n time to solve the problem. Yeah, from the beginning, the sorted list is empty. Then you need to insert the numbers. So for example, when you loop through this number 2 first, you need to insert this number 4. When you loop through this number 4, you need to insert this number 3. Yeah, because this number 4 has a distance more than this distance 2. you don't need to pop it out. You just need to keep it there. Yeah, when you loop through another number, maybe here is a 5, you just need to insert this number too. Yeah, let me go to the Jupyter notebook to explain a little bit about the sorted list and about what kind of functions I'm going to use. And then I'm going to finish the code in the code editor. Yeah, so for the sorted list, basically we need to pip install if you are using Jupyter notebook. Yeah, if you are using the IDE from the Leetcode, you need to use this kind of from sorted containers to import this sorted list, because that is not inside the Leetcode. You have to import. It's not like some libraries you can directly use it, like some math libraries like this inf, you can directly use it, the infinite. But for you have to import it from this sorted containers. Basically, we're gonna use two operations for the sorted list.add. This means we're gonna add a number inside the sorted list. For example, we have a sorted list like random numbers inside, but this sorted list actually every number is sorted. Yeah, like 1, 2, 3, 4, and 5. So when you add a number, that is just log n time. When you add 3 numbers from an empty sorted list, it becomes 1, 2, 3. And you can also use update, but here I'm not going to talk about update, because here basically we just use add and bisect left. The sorted list also has the bisect left function. So this method is totally the same like the bisect left for an array in Python. So here, for example, we have a number like 10 to 14. Now we want to check this number 12. Yeah, because for our implementation, we just need to check this number, if this number is closest to which number. Yeah, so this means we can use bisect left to check this number 12. It means we're going to insert at this position. So this is the index 2. So this means we find a closest position. Yeah, but sometimes we have some edge cases. For example, here, I'm going to put a negative infinite and positive infinite inside as borders, because here I'm going to deal with some edge cases. Otherwise, we have to use if to check if there are edge cases. Basically, for example, this one. From the beginning, for our sorted list, we have a negative infinite and positive infinite. Then we are going to add two numbers, 1 and 6. After sorted list, it will be something like this. 1, 6, and negative infinite and positive infinite, but they are in increasing order. Now we are going to use bisect left to check. If we are going to use a bisect left like 8, so what is the index? It is 3. So if we don't have this infinite, it means our index will be out of the range, so we have to check it, use if. Here we added an infinite and a negative infinite. It means we don't need to check, because at this position we're just gonna compare with this number. For example, this 8 compare with this number. So this means this infinite minus 8, it is still infinite. And then we will compare with 8 minus 6, it is 2. So it means this is the closest number. So the closest distance is 2, because 8 minus 6, it is 2. Now you know why we use a negative and positive infinite. Because if we have 8, normally the closest number is 6. But when we use a bisect left, we find the index 3 at this position. So it means we're going to compare with infinite minus 8 with 8 minus 6. So what is the minimum? The minimum is for the number is 6. The minimum of the distance is 2. And for another situation, it is like this. We still have 6 and 1. After sorted, it will be 1 and 6. But if we want to search a number like 0, so it is at the index 1, because it is not at index 0. It is not at index 0 because we're going to insert after this minimum position. It is index 1. So this means we're going to check 1 minus 1, it is 0, but 1 minus this minus infinite, it is infinite. But we're going to use the minimum number, so it is 1. Basically for the insect left, if you are using insect left, it gonna choose the for example, this is 1 and 6. So it's gonna choose the number more than or equal to this number. if you're gonna use insert this 0, it means it will be here, so the index will be 1. If you are going to insert with 1, so let's check, so it will be this one. It will be more than this number, more than this minus infinite, so it is 1. If you are using bisect left 2, so it means more than this one, it should be 2. Yeah, it should always be more than the previous number. Yeah, if we are using 1, it is more than this minus infinite, it is 1, but less than and equal to the next number, it's this one. Yeah, now let's go to the code editor to finish the coding. As I said, we're gonna use the sorted list. We need to import it first. So from sorted containers, so the sorted containers have many useful class. So there are also many useful packages. So from here we're gonna use the sorted list. There are also sorted set, sorted dict, but here we're gonna use the sorted list can solve the problem. Yeah. Now we can use the sorted list directly. So the sorted list, I'm going to define two variables, sorted list as the sorted list, and the result, it will be the infinite, because I'm going to return the minimum of the result. Yeah. Finally, I'm going to return a result. Now I'm going to check, like here, for the first index, it is 4, and then my I index is 4 and Z index is 2. Next, it will be go to 3, and here will be 4. Yeah, but for me, as we can use a zip to make the index easily, to search its numbers easily, not to check I and Z to loop through one by one. Now we can use a zip. So for the number and target value in zip with numbers, with numbers, and another one should be numbers x. So this means for the first one it will be 4, 3, 2, and 4. This is numbers, and then it will be start from x. X is the index. It's also the distance. So from 0 to distance 2, it is index 2. So this means the distance is 2. So from here, so for the first zip, it is 4 and 2. So for the next one, it is 3 and 4. So for this 4 and 3 will always be ended into the sorted list. So the SL dot add this number n, it means the number should be added to the sorted list. Then we're gonna check the index. We're gonna check the insert position for the bisect left. So the index should be the sorted list dot bisect left with this target number. So here the target means for example, this number 4 is target, and 3 and 4 is inside the sorted list. Now we got an index, and then we're gonna check the final result. So the result would be the minimum of result with sorted list index minus target with sorted list with the target minus sorted list index minus 1. Let me explain this one first. So this zip means it will only take the sorter length of the array. For example, the sorter one from here is 2 and 4. From here it is 4, 3, 2, and 4. This length is 4, but 2 and 4 length is 2. But for this zip, it will only take 2 tuples, 2 and 4. This means it is okay. There's no errors for the zip. And also for this sorted list dot index minus target. This means let me go to here. So this means, for example, if we are going to use the bisect left 8, we have a target number with 8. So this 8 means the index, the sorted list with this index is 3. This index should minus the target. So let me go to the code editor. So this means this sorted index it's an infinite number, should minus this target, but should also compare with another one. It is the target minus the value before the index before it. It is this number. Yeah, but it need also to compare with this 6. So this 6 is index minus 1. So for the sorted list, index minus 1, it is 6. And this 6 is target, should minus the previous number. It is 6. Now let me run it to check if it really works. Yeah, here I should add import. It's import sorted list from sorted list import. Yeah, from sorted list, from sorted containers import sorted list. And this one should be SL should be the sorted list. Sorted list should add this number. Here is out of range. Yeah, because here inside, as I explained, we're gonna use the minus infinite with the positive infinite. Otherwise, it will gonna out of range. We have to check the conditions. If the index is out of range, we have to use if to check the conditions. So this is why we need to add a negative infinite with positive infinite, and then we can avoid the index out of range problem. Now you can see it works. Now let me split it to check if it can pass all the testing cases. At the same time, let me explain about the time complexity. As you can see here, this is just a for loop, so this is on. And you can see also it's pretty fast from here. It's 90%. And this time complexity for here, it is just on. This is a for loop. And for this add operation and bisect left operation, if you check the API from sorted list, it is just log n time. So this is why we're gonna use this sorted list to solve the problem. Yeah, and here is just 01. Here is the log n. So the final time complexity is n log n time. Thank you for watching. If you think this is helpful, please like and